In this video, I will go over the solutions to Worksheet 6.1a, problems 1 through 18. Before I go over the answers to Worksheet 6.1a, I want to talk a little bit about distance. Starting with the obvious, as you move across a number line from left to right, numbers become larger and larger. It's always easy to tell which number is bigger when the numbers are positive, but remember, when you have negative numbers, the more negative the number, the smaller the number. If I want to find distance between any two numbers, you always want to take the larger number minus the smaller number. The distance between -6 and 4, the larger number is 4 minus the smaller number is -6. 4 minus a -6 is 4 plus 6, so the distance here is 10. The distance from -10 to -4, the larger number, -4, minus the smaller number, -10. -4 plus 10 is 6. The distance here is 6. The distance from 6 to 16, the larger number is 16, minus the smaller number is 6. This distance is 10. The distance between two numbers vertically is still going to be the larger number minus the smaller number. In this instance, 7 is the larger number minus the smaller number, -1. 7 minus a -1 is 7 plus 1, which is 8. The distance here is 8. The larger number is -2, minus the smaller number is -6. -2 plus 6 is 4. The distance here is 4. From 2 to 10, the larger number is 10, minus the smaller number is 2. The distance from here to here is 8. To write vector RS in component form, I plotted the point R and plotted the point S. And then to get from R, the tail, to the head, I must move right 8, up 3. So in component form, the vector is 8, 3. To write vector PQ in component form, I plotted the tail, P, and the head, Q. And to move from P to Q, I needed to go right 9 and up 0. So in component form, the vector is 9, 0. To write vector AB in component form, I graphed the tail A first and the head B. To move from the tail to the head, I need to move left 12, down 11. So the vector in component form is -12, -11. To graph vector PQ in component form, I graphed the tail first, 10, 4, then the head, 1, 2. To move from the tail to the head, I must move left 9, down 2. So in component form, we have vector -9, -2. To write vector PQ in linear combination form, P is the tail because it comes first, and Q is the head. Plotting the tail and then the head, I need to think of how far I need to move to get from the tail to the head. I will need to go left 9 and up 9. The number in front of I is always how much you move right or left, and the number in front of J is how much you move up or down. To write vector RS in linear combination form, I began by sketching the vector RS. The tail is at 3, -9. The head is at 6, -9. To move from the tail to the head, I would need to move right 3, so 3i. I do not need to move up or down, so plus 0j, which simplifies to 3i. Vector RS in linear combination form is simply 3i. To write vector AB in linear combination form, I began by plotting the tail, A, and then the head, B. We want to always start at the tail and move to the head. And to get from the tail to the head, we need to move backwards 12 and then down 4. The number in front of I is the amount you move right or left, and the number in front of J is the amount you move up or down. So in linear combination form, vector AB is -12i minus 4j. To write vector PQ in linear combination form, I began by plotting the tail and then the head. P is the tail because it begins with P, and Q is the head because Q comes second. To move from the tail to the head, we would need to go back 3, down 8. The number in front of I represents how much right or left, and the number in front of J is the amount up or down. So vector PQ in linear combination form is -3i minus 8j. You can draw a vector starting at any point, but a vector in standard form starts at the origin. So we will start at 0, 0, and from here we will move left 8, down 4. Moving left 8, down 4, we draw an arrow, which is the head of the vector. Then we connect the tail to the head, and we have the vector in standard form. If we want to start the vector at coordinate 2, 4, we plot 2, 4, and from here, move left 8, down 4, draw an arrow, and connect the tail to the head. To graph a vector, you want to start at a point, and the number in front tells you how much to move right or left, and the second number tells you how much to move up or down. If you're going to graph in standard form, the initial point, known as the tail, must be at the origin, and then we will move right 7, up 0. At this location, put an arrow, which is the head, and connect the tail to the head, and we've graphed vector R in standard form. If we would like the vector to start at 2, 4, I plot the point 2, 4, move right 7, up 0, put an arrow, connect, and we've graphed vector R with a tail at 2, 4. To graph this vector in standard form, you want to begin at 0, 0. Then we will move left 1, down 6. Moving left 1, down 6, I put an arrow at that location and connect the tail to the head. And we've graphed the vector in standard form. If we would like to start the vector at coordinate 2, 4, I plot the point 2, 4, and from there, move left 1, down 6, draw an arrow, connect, and now we've drawn the vector with a tail at 2, 4. A vector can start at any point, but if we are graphing in standard form, we want to start it at the origin. So I went to the origin, and then from that point, we want to move left 3, up 7. So moving left 3, up 7, I put an arrow in that location and connect the tail to the head, and we have graphed the vector in standard form. If we would like the vector to start at 2, 4, I plot the point 2, 4. From this point, move left 3, up 7, put an arrow, connect, and we've drawn the vector with a tail at 2, 4. To graph this vector, R comes first, so R will be the tail. S comes second, so S will be the head. They told me the location of both R and S, so I plot the point 1, -4 for the tail and 7, 9 for the head and connect. We've drawn vector RS. To draw a graph of vector AB, because A comes first, A will be the tail, and B comes second, so B will be the head. I plot the point -2, -9, and that becomes the tail. I plot the point -10, -5, that becomes the head, and we connect the tail to the head, and we have graphed vector AB. I want to write vector AB in component form, so I sketched the vector, plotting the point 3, 6 and 2, -10. A vector, we always move from the tail to the head, and the number in front tells me how much I need to move right or left, and the number at the end is how much I need to move up or down. Again, moving from the tail to the head, I would need to go back 1, down 16. So the vector in component form is -1, -16. To write vector AB in component form, I sketched the vector, starting with the tail, 3, -3, and the head, 2, 9. We know that 3, -3 is the tail because it comes first. Okay, then the number in front is how far we need to move right or left, and the number in the back is how much we move up or down. We always want to start at the tail and move to the head. So I need to move left 1, up 12. So vector AB is in component form is -1, 12. To write vector AB as a linear combination, I sketched the vector, plotting A, the tail, and B, the head. The number in front of I is how much we need to move right or left. The number in front of J is how much we need to move up or down. We always want to start at the tail and move to the head. So we need to go left 7 and then up 11. So the vector in linear combination form is -7i plus 11j. To write vector AB in linear combination form, I sketched the vector AB. A comes first, so A is the tail. B comes second, so it's the head. The number in front of I tells me how much to move right or left, and the number in front of J tells me how much to move up or down. We always want to start at the tail and move to the head, so we will need to go left 4, down 3. Vector AB in linear combination form is -4i minus 3j.